So have you ever seen someone take a little bit of code and make it a gigantic possible space of capability? I got to see that in a special person who's now going to be visiting the Cozy AI Kitchen. I'm delighted to welcome who I think is like the Mozart of the .NET software engineering world, none other than Stephen Toub. Stephen, hello, welcome to the kitchen.
Thank you for having me.
Well, Stephen, I saw you take a line of code and make it so much more, but maybe some brief background, 20 years in .NET, I understand?
Something along those lines, yeah. It's been a wonderful passion for the last decade or two. Most of that time I've spent focused on the libraries that make up the .NET stack, as well as sort of performance end to end. But for the last year or so, it's been a lot of AI as well, trying to ensure that, or ensuring that .NET is a terrific platform for developers to incorporate AI. A lot of folks have massive .NET application services that are 3 million lines of C#, and the key message is with a little, AI magic, you can make those applications even better. And we're trying to make it really simple and really easy to just augment your existing applications or greenfield applications with the amazing models and services that have come about for AI.
Well, without further ado, Stephen, would you begin your concert, please? Thank you.
Sure. Great. So all I have here is a simple new C# project. I've changed console line, from hello world to hello John. And we're going to take a tour through the various APIs that are available, or some of the available APIs, to get started incorporating AI into your applications immediately. And the reason I'm starting with a blank slate is to highlight that you don't need anything else. You can just get started, copy and paste into your existing applications and get going. So one of the really nice libraries that's available was actually only recently introduced. If you just say OpenAI, import the OpenAI library from NuGet, this is the sort of the official C# client for using the OpenAI service, which is one of the premier services available for doing AI. And on any time a new OpenAI feature is released, this client gets it on day one, and you can start writing some really amazing applications with just a couple lines of code. So I can say OpenAI client equals new. I can give this my API key. We just add another namespace here for using system.client model. So I can say API key, and I'm going to pass in environment variable. Get environment, it's a little smaller so you can see it, environment variable, just because I have my own credit card linked up to the service, and I don't want everyone in the world to be able to use my token. So I'll say my environment variable name, which is API key, and to access this.
And Stephen, we're at 4 lines of code here.
Yeah, 4 lines of code. So system, this is new, is the API key credential. That's fine. API key credential. There we go. So now I have an OpenAI client, and there are a variety of things that I can do with this. I can do audio, I can do images. The thing that we're going to do today is chat. This is just sending messages back and forth, basically text-based communication. So here I'll say var chat service equals this. And now I can use this chat client to perform operations. Now I do need to tell it which model I want to use. There are multiple models available. For our purposes, I'll say GPT-3.5 Turbo, but I can also say GPT-4 or GPT-4o or whatever. And now I can just make calls to this. So I'm going to say console.writeLine, and I'll say await chat service, chat async, and I'll say, hello, my name is Stephen, right?
Hello, John. Hello, Stephen. There we go. 6 lines so far.
Yeah, so I run this, and the model comes back and says, hello, Stephen, nice to meet you. How can I assist you today? So this is the model responding to my request. So, and I could ask it another question like, what, I don't know, what is, or why is the sky blue? Okay. obviously I don't have that answer in my program, but it's going off to the service and it's saying the sky appears blue because whatever. So we're actually talking to the AI service, getting back a response, and it took close to zero code.
Stephen, can you slow down a bit?
Yeah.
So this is just 5 lines, and we have the API key, we have the model selection, and chat's just running by itself.
Exactly. And we can also, in another 2 lines of code, we can make this streaming where rather than setting off the request and getting back the response and just outputting the whole thing to the screen when it was done, we could also have it come in token by token as the model is producing the response. We could just have that streaming into the console as well.
So it would feel faster that way while it's streaming.
Exactly. The time to last token would be the same, but we would see it as it was coming. And in fact, we can see that. So let me just change this a little bit. I'll say await for each var result in complete. I'm going to change this to be chat streaming async. This should not be await. And I'll put the same question I had. Why is the sky blue? Now, each of these results that comes back is an update containing some number of tokens. So I'll also say for each update in result.content update, and then I'll just print that out to my console, update.
So this is like the ketchup coming out of a squeeze bottle instead of a glass bottle.
Exactly. And so as it was way too fast to see, but let me try it with a slightly longer thing. Let's say, write a poem about cozy AI kitchen.
Ooh. It's going to work harder now.
And you can see it streaming in.
Streaming. Oh my gosh, the ketchup is coming out drop by drop.
Yeah, exactly. So this is an absolutely great way to write your code if you want to talk to OpenAI specifically. And Google has its own client library for talking to Gemini, and you could use HTTP client to talk to Mistral or to Hugging Face or whatever it might be. But one of the things that we kind of live and breathe by in software development is abstractions. We don't, if I want to, work with a stream of data in .NET, I don't write one function for talking to file stream and one function for talking to memory stream and one for network stream, for buffered stream, for crypto stream, for deflate stream, for broadly stream, for whatever. I write one function that works in terms of stream, system.io.stream, and then my caller can use it with any of those concrete implementations that comes in. And we want to be able to do the same thing here because we want to be able to write our whole application once and then parameterize it with, well, over here I want to talk to OpenAI, but over here I want to talk to a model running locally via Onyx Runtime or PyTorch or built into the Windows Copilot PCs, or over here I want to use Mistral, or whatever it might be. We want to be able to use one object model and then parameterize it. And
it gives you flexibility, you're saying.
It gives you a lot of flexibility, and you have to learn one API. You don't have to change that code again. And then you can just change it, maybe in configuration, maybe in startup code, whatever it may be. So this is where semantic kernel enters the picture. Semantic kernel is a .NET library. You grab it from NuGet. It's actually multiple libraries. It's often described as one thing, but it's really a layer of things. You've got a bunch of higher level components that do really interesting things around planning or around prompts or around plugins or whatever. But at the bottom, you just have this Microsoft semantic kernel abstractions library that provides these core abstractions for what does it mean to talk to a chat service. And then you have different concrete implementations for the OpenAI implementation of that, for the Gemini implementation of that, for the Mistral implementation of that, and so on. So I'm going to come in here and I'm going to make a few changes. First, instead of creating new OpenAI client like I did up here, I'm going to use the concrete implementation of the OpenAI chat completion service from semantic kernel. And here I just give this the same model that I provided earlier, the same API key. And I can do the exact same thing we saw where I could say console.writeLine await chat service.get chat message content async. Hello, how are you? And if I run this, and presuming I haven't made any typos, we say, hello, how are you? And we get back a response from the service. But the interesting thing about this is while this is an OpenAI chat completion service, I could have also just typed this to be iChat completion service. So this is that abstraction, this is that interface, which then means that I can talk to different services without changing the rest of the code in my application, simply by changing which interface I'm using.
I can go multi-model, as you're saying, Stephen?
Multi-model, yeah, multi-model, multi-service. Because this is multi-model, and that I could change GPT 3.5 Turbo here to GPT 4.0.
Got it.
But what do I put here if I want to talk to Gemini? Well, there's nothing I can put there to talk to Gemini.
Right.
But I could come here and I could say, Gemini, our Google AI Chat Gemini Chat Completion Service. Again, I need to give this a model. Well, Google doesn't have GPT 3.5 Turbo, but it does have Gemini Pro. And let me give it my API key, again, from an environment variable. This isn't my OpenAI key, but this is my Gemini key. So I've just changed this line here. I keep the rest of the code the same. Now when this goes off, I get a response coming from Google, from Gemini, instead of from OpenAI, and yet I haven't changed the actual interaction. And this code that interacts with it could be spread across many services, across my project, lots of different things, lots of different prompts. But the only thing I've changed is where this is, injected. And I could do the same thing with a different service. If I wanted to talk to Mistral AI Chat Completion Service, I can say the model is Mistral Small, because again, it has different models. And I could have my Mistral API key. And again, I get back a different answer, this time coming from the Mistral service. So again, I didn't have to change the actual logic doing the interaction.
So it's kind of like one of those like power adapters, an international power adapter sort of.
Yeah, you don't have to change your laptop to plug it in Britain versus in France. You just change the adapter and you're still able to plug it in both places.
Power of abstractions, I see.
The power of abstractions, exactly. So once you're able to do this, you can then start doing a whole lot of interesting things in the code around these abstractions and not worrying about exactly who you're talking to. So for the rest of this, I'll just assume I'm talking to OpenAI, but the same concept works with the rest of these things.
Yep.
Now, I'm going to increase this a little bit to kind of make this more sort of like a chatbot, a little bit more fluent. So I'll say, I'm going to put this in a loop. And I'm going to read a question that I type at the console. So I'll say question. I'm going to have my question, just read it, console.readline. And then I'll put my question into the message that I'm sending to the service. And so now in a couple more lines, I can say, hello.
Yeah, it's interactive now.
I think now it's interactive. So my name is Stephen. Hi, Stephen. Nice to meet you. The interesting thing, though, is these services are generally stateless. So now if I ask it, what's my name? It has no idea. Because even though I just told it, this is a brand new request. So we're going to make a few more tweaks to this to allow it to retain that context, basically store the whole conversation and resend the conversation back each time. So I'll say chat history, create a new chat history here. When I read this in, not only am I going to send it to the service, I'm also going to say add user message with my question. I'm going to take the response, and rather than just printing it out directly, I will do that, but I will also say add in this response message back into my chat, and then I'll just send that chat instead of the question. Okay. So now with just a couple more lines, we get the exact same experience. I can say hi, it says hello. I can say my name is Stephen. And eventually it should come back and say, it's nice to meet you. And then I can say, what's my name? And it knows my name is Stephen now because I've re-provided that context.
The history. And the history is also an abstraction across anything too, you're saying.
It is. I could again come in here and I could just change that back to be Google or Mistral or Onyx Runtime Gen AI Chat Completion Service to talk to a local model or whatever, and it would all just keep working. The interesting thing now, though, is if I say, how old am I? The model has no idea how old I am, right? So I need to be able to provide additional context to allow it to answer questions like this. Now, I could come in and I can proactively add that information. I could say, add user message. Stephen is, I'm going to make up a number, 21 years old.
Oh, a nice age.
Wouldn't that be lovely? And now if I do the same thing again, and I say, my name is Stephen, how old am I? Now it says, oh, you're 21 years old because I've provided that additional context. It's able to pull not only from all the information that made up the model, but also all the information I've provided in my prompt.
Yep.
But if I ask, how old is John, it's not going to have any idea. And it's going to maybe probably make something up like, oh, John is a biblical name. John from the Bible is this, 7,000 years old or whatever. So what we instead want to do is give the ability for the model to gather its own additional context. And one of the ways that you can do that is with a really cool capability of many of these models called function calling, where you can give it a list of functions where you can say, I'd like an answer to the following question. But if you don't think you can answer that question yet, here are some functions that you can invoke. Let me know if you'd like me to invoke any of them for you. I'll do that and I'll send you back the answer, and then you can use that answer as part of your additional context. So let's come down here and we'll add another class. We'll say class, and I'll call this demographics just because we're talking about people's ages. And I'll add a method here, public int get person age, that'll take in the person's name. And I'll say, if the name is Stephen, then let's say 21. If the name is, Elsa, let's say she's 20, I don't know. Anna, let's say she's 18, and anyone else, let's say they're 30, right? So now we've coded this local function in my own process, and I'm going to make one tweak here, and I'm just going to mark this as a kernel function. What is this kernel thing? Well, semantic kernel recognizes that there's lots of different state that you might want to pass around and different capabilities. And so it has this type called a kernel. So I'll just new this up, and there are a variety of ways to create this. But I'm going to tell the kernel to import a plugin from my type demographics. And all this is doing is creating this little object called a kernel function, which is just a wrapper basically around this function here. And then it's creating a kernel plugin, which is just a collection of functions, and it's adding that into the kernel. And if I were to explore this, we can see that there's plugins here. This is just a collection of these plugins. But the neat thing is with basically one or two more lines of code, I can expose this to the service. So I'm going to create a settings object. This is where I basically configure the service. And you can see there's a whole lot of ways that I can configure how this particular service behaves. There's also an abstraction for this as well. And I'm going to come in here and I'm just going to say the tool call behavior is that I want you to automatically invoke any of the functions that I provide to you.
And Stephen, I want to note for the audience here, when semantic kernel was coming out of the ground, when Stephen Toub showed up with the most beautiful way to call functions, jaws dropped. So I just want to give credit to Stephen for this function calling moment. Everyone, please go ahead, Stephen.
Well, thank you. Now all I've done is I've provided these settings and these kernel to this system. So now when I come in and I say, my name is Stephen, how old am I? Now it says you're 21 years old. I don't have that line here anymore that says I'm 21. It got it from here. And if I were to ask, how much older is Elsa than Anna? Elsa is 2 years older than Anna because Elsa was reported as being 20. Anna was reported as being 18. Now, that looked kind of like a little bit of a black box, but we can peer into exactly what's happening here by plugging in and turning on things like logging. Now, this gets into how most developers in .NET do things like logging, and that's generally via dependency injection. You have some sort of startup code that's configuring your ASP.NET dependency injection container or your dependency injection container in Maui. I'm going to simulate that here by just creating my own in my console application, but you would generally do this by just plugging into whichever one is part of the environment that you're in. So I'm going to create a service collection here using Microsoft Extension's dependency injection. We'll call this a C. And now I can actually, rather than configuring these things directly here, I can just configure them as part of my dependency injection container. So I'll say add OpenAI chat completion, and I'll just plug in the same things that I had up here. And I can now delete this code. Here I'll say, I have my iService provider, which is how a consumer gets this up. We'll call this services, build service provider. And now I can just fetch my chat services from my dependency injection container. I can even do that for the kernel as well. I could say sc.add kernel, and I could say .add from plugins.add from type demographics. Now I can delete this, and my kernel just becomes services.get required service kernel. In fact, if I wanted to, I could even, kernel itself wraps that same provider, so I could just get the chat completion service from the kernel. And now I can add any other things into my collection, into my dependency injection container that I want. For example, I could say add logging. So I could say I want to add console logging, and I want to do trace level logging. So basically, show me everything that's coming out of this. Now, if I run this, we can see right off the bat, we saw that this get, we're peering behind the curtain, like this get person age was imported into this kernel object. And now if I say, how old is Stephen? We can see a bunch of things are happening. First, we saw the actual request that was sent off. We see that it took this many tokens. And then the response to that came back with a tool request for us to invoke get person age with the argument Stephen. We proceeded to invoke it with the argument Stephen. It took 0.005 seconds. We got back a result 21. We made another request to the service, this time consuming 78 tokens, and we get back the answer 21. So you can really see how you can kind of build up this stuff incrementally and easily. And I can put anything I want into my dependency injection container, the world of plugins available from Microsoft extensions, Microsoft extensions.http.resilience or whatever it might be. And all of that feeds into the rest of the system as well. And there are various ways that we could extend this further. For example, maybe I don't want to just allow it to invoke every function I've told it about. Maybe I want to kind of insert myself into the middle a little bit and get permission. Maybe I want to do some more, sort of around responsible AI. So Semantic Kernel supports this kind of middleware, these kinds of filters, by writing a custom filter class. So I could say, let's call this permission filter. And I want to have an I function invocation filter. I'll have it implement that for me. Now, if I can, these form sort of a chain, so I can delegate to the actual implementation by just saying, do the next thing. But rather than always do the next thing, I could ask a question like, if console, console.writeLine allow invocation of, and I'll output some information here. So I'll say context.the function that's being invoked, and maybe with the function arguments as well. So I'll say string.join with context.arguments.
Sort of like the immigration thing when you're coming into the country, or?
Yeah, should we allow you to come in or out? Do you have your U.S. passport? Are you allowed in? And so we'll make this really easy. I'll say if the user typed in yes, then do the next thing. Otherwise, let's throw an exception. We'll say exception, user rejected request, something like that. And now all I need to do is get the rest of my system to use this. And I can do that with one line up here by saying, I'm just going to add an instance of this. It is an I function invocation filter. I'll tell it which one I want. And that's it. And now all this other code is automatically configured based on that. So now when I run, I still have it running from before. Close this. Now when I run this and I say, how old is Stephen? You can see we send off the request just like before, but now when it's going to invoke it, now it's pausing and it's saying, should I allow the invocation of get person age? I'll say yes. And then we go as before. Now, if I do it again, how old is Elsa? Exact same thing happens. Now I say no. You can see it got back this user rejected request and it failed, and the system comes back and says, I'm sorry, I'm unable to do that. So with very little code, you can create these really powerful compositions of a lot of functionality where you write your logic in one place, you configure it in other places, and everything kind of holds together nicely.
Wow. Okay. So, Stephen, the concert was delicious for the kitchen. I just want to say that I'm off camera, but my mouth is like gaping. When I see, I'm a new to the .NET sort of a developer world. I can program in other languages except the one. This is the one I ever learned how to use. And
we'll fix that, John.
And then in the last, since the Maeda kernel, I've been sort of like catching up. But to watch you do this, I learned so much. So thank you. And those viewers who are new to it too, I hope you enjoyed it as well. Stephen, do you have any parting thoughts for engineers who are just too busy right now to learn this AI stuff? I mean, they're pushing regular code and their bosses are saying, figure this AI thing out, but it's extra time.
So I guess maybe three thoughts. The first is the tooling is exceptional at helping with this kind of stuff. You saw a whole lot of auto completion happening, not only just regular stuff from the tool, but I have GitHub Copilot. So it's auto completing things for me. It's recommending. And most of the time I was just having to accept. So I'm using AI as part of my development, not only using AI in my application. So I highly recommend whatever tool you want to use for it, do that. Number two, there's plenty of documentation on the stuff. You pick whatever library you want to get started with, read the docs. There's tons of getting started examples, really easy way to get started. And number three is it's actually really easy to get started. You saw with 2 lines or 3 lines of code, we had our first round trip to the server. With another line, we were streaming. With another line, you can get started really easily, with whatever service you want to use, and then go from there. So just take that initial leap, try things out, and build up from there.
I can't tell you how much joy I'm filled with this concert. It really meant a lot to me as a person in the Cozy AI Kitchen, hoping to see more AI engineers emerge. Thank you, Stephen, for that concert. Just all of you, those 3 points, it is possible. GitHub Copilot is here. And just rewatch this concert. I'm going to be watching this concert multiple times. So thank you, Stephen. And goodbye, everyone.
Thanks for having me.